I generally try not to go in much depth of topics which use knowledge of other subjects, but sometimes it becomes unavoidable. Actually, you may see that EK notation is generally more used than EP notation. We will connect the two different notations and will also discuss the two significance of differentiation which we performed in the last lecture. In the last lecture, we talked about energy of free moving particles that have mass even at rest. But what about quasi-particles? For quasi-particles, momentum is given as reduced Planck's constant multiplied by wave vector, where reduced Planck's constant is equal to Planck's constant divided by 2 pi, and k is representing wave vector. In quantum mechanics, the momentum of a particle is commonly described by its associated wave function, which is a mathematical representation of a particle's wave-like behavior. The wave function contains wave vector, which represents direction and magnitude of the particle's momentum. Wave vector of the quantum particle depends on the momentum of the particle and is essential in determining the effective mass. Now, we do the same double differentiation as we did in the last lecture. Here, rather than differentiating energy with respect to momentum p, we will differentiate energy with respect to wave vector k. This particular expression is extremely important in quantum mechanics for determining the effective mass of different particles. In further units, you will be solving a number of problems involving effective mass, and most of the times it is already provided in the question. But the real question is how it is actually calculated. Obviously, you are not going to use a weighing machine. The answer is this expression only. If we rearrange it a little bit, then we will have this expression provides the desired relationship to calculate the effective mass in laboratory. This is how, by conducting various experiments in the lab and interpolating the data through numerical methods, effective mass is calculated. In the previous lecture, EK diagram could be drawn approximately even if you don't double differentiate energy with respect to momentum and having some basic knowledge of mathematics. Effective mass is calculated only through this formula. Such type of in-depth knowledge may not be used in competitive exams, but becomes quite essential points in interviews. Effective mass can also be explained as external force applied divided by the effective acceleration experienced by the particle. There may be different definitions and formulas for finding the same parameter, and you should remember all the formulas and use the formula as per the data provided in the question. It might be clear to you now, momentum p and wave vector k are directly related to each other. Therefore, you may see that in some books EK notation is used, whereas in some books EP notation is used. You might have noticed that all the things which we have studied regarding effective mass, we have always considered free particles. If the particles is not moving freely, then the above equations will definitely be requiring major modifications. But for now, it is sufficient for us to study freely moving particles only.